Today we will discuss about the perfect match layer PML. Firstly, I will tell you what is PML. PML is a artificial absorbing boundary layer which are used for the computational domain, outer of the computational domain. Why? Now why we are using for that? So we are using for the electromagnetic wave, acoustic wave, yeah, any wave which are going to boundary, and without reflections it becomes absorbed completely by the slowly. What the purpose of that? It's the purpose for the simulations of finite domain and real worlds to which are used for the open boundary conditions. We do approximate for that, and the main target of PML is reflection should be zero, and wave should be completely absorbed, and realistic result for the antenna design, meta surface simulations, optical device simulations, which are very used for that. And now I am telling you how it works. So basically it is the mathematical transform based on that, and complex coordinate stretching, which is also said to be a complex coordinate stretching. And when wave enter to the PML, then propagation constant formed by the complex, and due to complex stretchings, the wave of amplitudes and decreasing to slowly, and the wave is completely absorbed. Due to this process, there is no reflections, and due to which boundary and PMLs of the impedance matchings perfect. That is called perfect match layer. That is the reason behind it. We say the perfect match layer. Now a question is arise, where is use of that? So the use of electromagnetic simulations and acoustic wave simulations, seismic wave simulations, metasurface design, and optical device simulations, like as lenses, waveguides, photonic crystals, and the structures of that in 2D and 3D. In the 2D case, it is around as the as is, and in the 3D, it is around as the full box of that. Now I will do discuss about the type of PML. So that is three types: isotropics, anisotropics, and uniaxial. Isotropics means each and every direction absorption would be same, and anisotropic means uh, different direction have different absorption, and uniaxial PMLs means electric and magnetic fields that is different for different scaling. Now a question is arise, why we are using, what is the advantage of that? So the advantage is no reflection at the boundary, and relativistic infinite domain simulations, and efficient and accurate, which are very near to the result of real worlds. So thank you. So basically that is the basic idea of PML. Now we do discuss about the perfect electric conductors, that is PEC. So I'm telling what is PEC. PEC basically are those which have the infinite conductivity, and due to which resistivity becomes zero, and those wave passes through the electric current, but there is no drop voltage on that, and electromagnetic wave cannot be penetrate of PEC, and that is the theoretical model which are used for the simulations and electromagnetic theory, and due to which calculation becomes easy. Now what is the PEC of characteristics? So infinite conductivity, and skin depth should be zero, and no energy loss, surface current carries all the fields. Now a question is arise, what is the boundary condition of PEC? And the boundary condition is electric field of tangential component. Here tangential component of electric field would be zero, and magnetic tangential component of magnetic field would not be zero, but at the surface current due to which generated, it may be zero. Now a question is arise, what is the behavior of PEC with electromagnetic waves? So when electromagnetic wave incident on the PEC, then it would becomes completely reflected, and no absorption, no transmissions, and due to which absorption and transmission becomes zero. And due to reflections, PEC, that is called perfect reflector, also we can say that. So in this case, reflections coefficient becomes value of 1, and transmission and absorption coefficient becomes value of 0. Now a question is, why, where is the use of that? So that is the antenna simulations and waveguides and cavity resonator design, microwave device, and electromagnetic simulations in ideal boundary conditions, radar reflections design. That are many advantages for PEC. But PEC does not found in real worlds, because there is no any materials which have the infinitely conductivity, and some substance like as copper, silver, aluminum, that are good conductor. But and in all this case, PEC in some we take the as approximations. But in the high frequency applications and skin effects, metals of losses and ideal PEC, which have a model. If I will tell you the how we do represent the mathematically, so inside the PEC, and electric field and magnetic field becomes zero, but on the surface tangential component of electric field becomes zero.